Hey guys, welcome back to Python for computational biology. In this video, we're going to visualize some of the tabular data, the inflammation data that I've been playing with in the previous video where we did the means and things like that. So we're going to kind of look at it. I warn you, visualization in Python, in my opinion, not good compared to R. That's where R is just, R's awesome. R is awesome at like two things: statistics and visualizing data. So we'll do some basic graphs in Python, and you be the judge yourself if you took my R classes on how they compare. So let's go ahead and jump right in. All right, open up a Python notebook. Oops. Oh, so make sure you're already in this folder here, right? So SWC Python, the data folder. Otherwise, you're not going to find the data. So first thing, import numpy, load our data, numpy, load txt, fname, excuse me, I got the hiccups, inflammation, 01.csv, and then we got to tell it how they're separated. So delimiter equals, since it's a CSV, that means it's a comma separated file, so we give it a comma. Then we run it. I'm gonna actually, since I'm doing a new one here, I'm going to save notebook as, and I'm gonna call this one data visualization. There we go. Okay. So we're also going to do import matplotlib.pyplots. So matplotlib is a plotting library, and we're just going to import the pyplot function from it. And we're going to say our image is from matplotlib.pyplot, so the subpackage, show data. And then we're going to say matplotlib.pyplot.show. So what this is doing is we're saying, okay, first import the plotting library. So compared to R, for those of you that took R, this is like importing ggplot. Then we're going to say, all right, we're going to make this image, and we're going to use matplotlib, the subpackage of it, pyplot, and we're going to do image show, which is kind of like the function for data, which is the data that we just loaded right up here. And then, so this is making the image, and then we say, all right, use the same package and subpackage, and then just show it. Okay, so why didn't you show it? Oh, figure size with one axis. Okay. I probably apply plot, image, show data. There it is. Okay. I just had to rerun them. Okay, so each row here, so we have 60 rows. Each row corresponds to a patient in the clinical trial data set. Each column corresponds to a inflammation measurement. So you can see that all 60 of our patients start out with like no inflammation, and then it gets warmer, and then everyone kind of peaks at day 19 for inflammation. So they kind of all get swollen up around the same time, and then the inflammation goes down again over time. So per the claims of the study from Dr. Maverick, the patient take their medication once their inflammation flare-up begins. It takes around 3 weeks for the medication to take effect and begin reducing flare-ups, and flare-ups appear to drop to 0 by the end of the clinical trial. So let's plot this a different way. So let's look at the average inflammation over time. Let's put a annotation up here too. So this is heat map of patient inflammation over time. So this isn't average, this is just each patient's inflammation over time. So now we'll do the average. So av inflammation equals numpy dot mean data axis equals, remember, 0 and 1. So if we want to do average information, we have to have 0. If we wanted to do max per patient, we had to do 1. Av plot equals matplot lib dot pi lib dot pi plot av inflammation matplot lib dot pi plot dot show. So we always have to call show to show the plots that we make. So all right, so we've said, all right, this is our average inflammation. Take numpy spelled correctly and get the mean across axis 0. So that's the average inflammation per patient. So across the average this way on our heat map. Then we say, all right, we'll make our average plot as this thing in the background. And we say, take matplotlib, the subpackage pi plot, and then we're gonna, oh no. Pi plot dot plot. Take pi plot and use the plot function of our average inflammation, and then our last command here just says, okay, now show us what we made. So let's run that. All right, so you can see now we didn't have axes on here. It's not like a publishable graph, but you can see that we have, this is the time. So this is the weeks, right? Down at the bottom here. And these are the patients, or this is the inflammation over the weeks. So you can see the average goes up, 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 and right around week 19, which is denoted as 20 in here. And then it goes down, which is great. Let's see. And that kind of goes with the doctor's view that it takes 3 weeks for the medication to take effect, and then it goes down. Perfect. So let's try another plot. So let's look at the max plot. We'll do it like this: max plot matplotlib dot pi plot dot plot numpy dot amax data axis equals 0. And then we'll say matplotlib dot pi plot dot show. So we're going to show the one we just made. Okay. This is just taking the maximum value for everything and drawing a line to it. So you can see like the maximum value is at this 20 weeks or whatever, and then drawing straight lines connecting it just to see if it's linear, right? So it's taking kind of like the first 3 points, or the first point, the last point, and then the middle point. So let's do a different plot. So let's do min plot equals matplotlib dot pi plot dot plot numpy a min, and we're going to say data axis equals 0, and then let's matplotlib dot pi plot dot show to show what we made. And so you can see the minimum that is going across. So neither of these trends are like really likely. The fact that it's perfectly linear and that we have like a step up for the minimums would kind of give you pause to the data because there's not any noise in it at all. And that's why you get kind of these symmetrical things going on here as well. But that's because they probably just generated this data. But it's nice to be able to look at, like, see what's going on, I guess, plot it out. All right, so we can also group plot. So this is for those R people again, and I'm sorry if you haven't taken the R, to always refer to it, but I did make those courses first. But this is kind of like the facet plots that we did. So we can put these three plots kind of together, right? So what we're going to do for this is, if you're, we already did this, but I'll do it again in case you want to put this in a different file. So actually, let's see, do we want to, I already have them saved. So actually I'm not going to do this. So they already ran up above, and since we're still doing this, and we've already loaded the data. So what I'm going to do is fig equals matplot lib.pyplot.figure, and then we're going to say what our size is, and we're going to say it's 10.0 by 3.0. And then we're going to say access 1 is fig add, so we're going to add a figure as a subplot. We're going to say 1, 3, 1. Then we're going to say access 2 equals fig add subplot 1, 3, 2. And then access 3 equals fig add, and I bet you'll know what this one's going to be just intuitively. 1, 3, 3. Oops, I write 4. I'm really confused there. So access 1 set ylab. We're going to say this is average. So this is the y label, not plab, y. Oh, wait, what did I do here? Access 1 y label. And then we're going to say access 1.plot. So what one should we plot? And we're going to say plot the mean of data, access equals 0. So this is by patient. Access 2 set y label. And this one is going to be max. And then access 2 plot numpy. I'm going to say amax data axis equals 0. And then scroll down. Access 3 set y label. And this is going to be min. And then we're going to see access 3 plot numpy a min data axis equals 0. Okay, so let's take a break here and look at what we got. So the first thing is we're going to make a figure using matplot library with pyplot, and we're going to create a figure. And we're saying our figure size is going to be 10 units by 3 units, or 10 inches by 3 inches, or whatnot. Because this is all relative to like how big you print the file, right? So access 1. So the first plot, so we're going to make 3 pictures in one plot. So access 1, we're going to call our first plot. So we say fig add subplot. We're going to make it 1 row by 3 columns, and access 1 is going to be the first part, the first position on that row. Access 2, we say the same thing. So fig add subplot, 1 row, 3 different columns, and this will be the second position on that figure. And then access, oh, this should be 3. Access 3, fig add subplot, 1 row, 3 columns. This is the third position on that row. And then we say, okay, so now that we have access 1, 2, and 3, we're going to make the label. So we say set the y label for the first one is going to be our average plot that we made above. And then we're going to plot the average. So this is just the command from above. the second plot that we've saved here is going to be labeled max, and then we're going to use the plot function again. And then the third one is min, and we're going to use the plot function again. So then we do fig tight layout. So there's different layout functions, and we're picking the tight function. Then we do matplotlib pyplot save fig. So we're going to save this figure outside of our notebook, so it'll save it into our folder over here. And then matplotlib.pyplot.show, and then we're going to show it. Okay, fingers crossed I didn't have a typo, and I did. Oh no, I didn't. I did. It worked even though I have a typo somewhere. Line 18. Matplotlib py. There should be a plot here. Pyplot. Oh, so it just didn't save my file. It's in the save function. Okay, there we go. So you can see what it did is, like I said, it made a figure that's 10 by 3. So 10 this way, 3 this way. It added one row. So we have one row across. We have 3 different columns here. The first column here, access 1, we said to be the mean, and so our average. So we got that. Plot 2, we said to be the max, and we got our max right here. And then plot 3, we said to be the min, and we have our min right there. Beautiful. I say beautiful, but it is not as nice as R. I have a little partial, like R gets crapped on a lot, but R does some very nice stuff that Python can't do. So also, if you look over here in your Python folder now, I'm going to save this as data visualization, so I can close out of it. But if I double click here on this inflammation thing, now I have my plot forever immortalized in my files. So, okay, what are we at? 17 minutes. Man, I'm getting very good at like this internal clock that I have going on. So that is it for visualizing data. And we will be continuing on our journey with some loops and stuff. Even though we did loops already and the Linux stuff, we're going to be continuing on a Python version coming up, but with some data, so it'll make more sense than the loops we did before. Thank you for watching. Hit like, hit subscribe. You know the drill. I told you what we're going to do next. I hope you liked the video. I'll see you in the next one.